All right, this is section 11.5. In this section, we're going to deal with adding and subtracting rational expressions, but we're only focusing on ones in this section that have a common denominator. So that makes it nice and easy. So here we have a fraction that's being added, and notice that they have common denominators. If you have a common denominator and you're adding, all you have to do is add the numerators and place them over the common denominator, which is what I've done here. And then you simplify. So 5x plus 4x is 9x. And then at this point, then you can cancel any common factors. Well, we know that 3, right? 3 goes in this one time, 3 goes in this 3 times. Or that 9 divided by 3 is 3. So that's how they got the 3x. All right. And then you're going to set each canceled factor to 0, determine the excluded values, and notate the excluded value. But in this case, we canceled out a 3, right? So there isn't any variable factors to cancel, so we don't have any excluded values. Now remember, anything over 1 is anything, right? So that was a very, very simple example. Let's do another one. Here we have 3x divided by x minus 3 plus 4x divided by x minus 3. So the first thing we're going to do is we're going to add those numerators and put them all over the common divisor. And then we're going to simplify. 3x plus 4x is 7x, right? And then you're going to cancel any common factors. In this case, there isn't any common factors. And so we also then have not, we don't have any variables to exclude because we can't cancel, all right? Now, this is a common mistake, and I want to point it out to you. Some of you may say, well, why can't I cancel this x and this x out? Well, for one, this here is a product. 7 plus x is a product. Down here, this is not a product. This is a subtraction problem. And so you can only cancel out common factors. Remember, factors is what gives you the product in multiplication, right? This means multiplication, right? So you cannot do that at all. These are not common factors because this right here is not even a factor. It's being subtracted by 3. It's not even being multiplied to anything. So make sure that you don't make that common mistake. All right? Let's do another example. All right, here we have this polynomial, long polynomial divided by 4x plus another long polynomial divided by 4x. So we still have the common factors is being added. So we're going to do that first step. We're just going to combine everything and put it all on top of the common denominator. And then from here, you're going to what? Simplify, right? Common ones. So look at it here. Here we have a 5x cubed and a 3x cubed. 5x plus 3x cubed gives you the 8x cubed, which is what we got down here. And you continue finding like terms. Here we have 7x squared minus x squared. So that gave us the 6x squared. And here we have x to the first and 5x. These are like terms. So a negative 3x and a positive 5 gives me a positive 3x. And then positive 1 and a negative 1, they become 0. So remember, you can only combine like terms. Next thing you're going to do is you're going to cancel common factors. Well, in order to cancel common factors, you do have to factor. And so we have a polynomial on top that needs to be factored. It has a GCF of 2x. So I factored out a 2x. and then 2 times 2x on the denominator gives you the 4x. All right, so that's what we've done there. Is all we did was factor out a common GCF, right? That's all we did here. Now we're going to cancel common factors. Then we're going to set each canceled factor, what we reduced. We're going to take each common factor that we canceled. Well, the only thing that we canceled was a 2x, right? We're going to set that equal to 0 and find out what x cannot be. And remember, a number, 0 divided by a number is always 0. So you have to then denote the excluded value where x cannot be 0. So again, this is your answer where x cannot be 0. Now here we have 3 fractions we're adding. It's still the same procedure. You're just going to add those numerators and place them over the common denominator. So that's what I've done here. And then you're going to simplify, right? Simplify, remember, like terms. So here we go. The 3x plus 2x gives me 5x. 5x minus x gives me 4x, right? Then we have a positive 11 and a minus 4 gives me what? 7 minus 6, and we're left with a positive 1. So we've now simplified that fraction. And you're going to factor. After you've simplified, you're going to factor and cancel out common factors. So notice here we have 4x plus 1, 4x plus 1 is canceled. Go ahead and write our answer. Determine what x cannot be. So here we had 4x minus 1. We're going to set it to 0. We solve. We find out that x cannot be a negative 1/4. And so we're going to then note that this is our answer where x cannot equal a negative 1/4. Now that was dealing with addition. Now we're going to talk about subtracting rational expressions with common denominator. Well, if you recall, all right, recall right here that a minus b is the same thing as saying a plus a negative b. Well, we're going to apply that same principle or that same idea to rational expressions. So below here I have the fraction a over b minus c over b. I can change this minus sign to a plus negative, which is what they've done. And then I can rewrite that and put that all over as a plus a negative c over b. So that's all you're doing, is you're just changing the subtraction to addition and then following the addition rules that we just did in the previous examples. So here's a subtraction. I'm going to change this subtraction, right, to this plus minus here, right? It's the same thing. It's saying plus a negative of the second fraction. Then we're going to combine the numerators on top. Then we're going to simplify. 4 plus a negative 3 is 1x. And you cannot cancel any common factors here at this point. We haven't canceled anything, so there's no variable factors to exclude or excluded values. All right, so here we have a fraction with a common denominator of x plus 1. We're going to change that subtraction sign, right, to this plus negative. All right, then we're going to go ahead and put everything on top on our numerator over our common denominator. And we have 3x plus a negative 4, which does not reduce. And so there is also not any common factors to cancel out as well. And therefore, there's no variables that we can cancel or exclude. Then we're looking at here. Again, we have the common factor x squared minus 4x plus 3. Not common factor, excuse me, common denominator. So we're going to change the subtraction to addition. But this time, notice when I put my plus minus, I put the x plus 2 in parentheses down here, because this negative belongs to everything inside the parentheses. All right, this negative belongs to the x, and the negative belongs to the 2, positive 2. So we're going to distribute that negative when we go to put it on the numerator above the common denominator. So when I distribute it, right, a negative x times x gives me a negative x, and a negative times a positive 2 gives me a negative 2. That's real important. Now put it all over that common denominator, and then simplify. 2x minus x is x, and 1 minus 2 is a negative 2, excuse me, a negative 1. Now we're not dead yet. We need to factor if we can factor. So notice I've taken this trinomial here, and I factored it up here. Once you factored it, see if you can cancel out any common factors. Remember, this ends up being 1 on top. And we've reduced that. Now we need to determine what values can x that we need to exclude. So notice that I've taken this that we've canceled out here, set it equal to 0, and we find out that x cannot equal 1, and we need to notate that. And so again, here is our answer. And so it's very, very simple. Everything you've been doing, the only thing really that's new is that you are subtracting or adding, and you're combining the numerators, simplifying before you start to factor and determine your, you factor it and then you reduce it. And so you're applying some of the sections that you've done previously in this chapter. And that's it for this one.